by way of background, I'm not a PhD, but as you can see from my hair, I have a lot of experience. But I have worked 7 years with Cycorp in Austin. Doug Lennon hired me because they had published a description of the API for the Cyc engine that was used as part of the high-performance knowledge base project in the late 90s. And I had written a Java program that reverse engineered part of that. And they thought, oh, they should probably hire me, otherwise I might compete with them. But the opinion may be held here that Cycorp has not been successful, despite the tens of millions of dollars of government sponsorship that they received and continue to receive. And as a Cycorp insider, at one time I was the manager of all the programs, the project manager for several good projects, and the most impressive one that I was involved in was rapid knowledge formation. And I'd be glad to answer questions about Cyc technology versus other approaches taken in general AI. I think that Cyc could ultimately reach general intelligence. The roadmap involves going through hand entry of facts and rules. And for the most part, that's still the case. So it's likely, in my opinion, that someone else will achieve artificial intelligence, general artificial intelligence before Cycorp does. And my own work is mainly to address the deficiencies of what I thought their approach was, and while incorporating all their advantages. Now I can speak to that in a question and answer session. And that really talks a little bit about cognition. My own work is in natural language processing because I think a good way to achieve artificial general intelligence is to create a system that can be taught by dialogue. And dialogue is not really a solved problem, but some very good dialogue systems were built at the University of Rochester, for example. And I want to use English dialogue as a way to build a knowledge acquisition system. And the knowledge acquisition system would have as its primary goals the acquisition of linguistic knowledge and procedural knowledge, that is skills, and thus bootstrap itself into full coverage of English language, and ultimately get to the point where it knows enough about programming, the application domain, the domain of algorithms, and the domain of composition, so that I could give it new skills or teach it new skills without having to program each one in detail. So I think in that way I could bypass some of the problems that have prevented Cyc from becoming more widespread use. So I'm going to describe a few things about my work to fill one of the time slots that will be absent today. And then three of us will take questions from the audience, and I have some prepared questions based on what I heard, and then some that were nice, well suggested by John Charles in advance. So I have an open source project to create artificial intelligence. And if somebody in this audience doesn't create it first, I aspire to do it myself. So open source attracts me because of the vast momentum in the open source movement, the collaboration is possible. And then the fact that open source lends itself to incorporating other people's components that happen to have an open source license. So the vast amount of my work is simply patching together other people's work, especially when it comes to content. So the very first thing I did in August of 2006 was I converted the OpenCyc content to RDF. And as some of you know, there's a lot of momentum again in the semantic web community to link open data. And the OpenCyc is the most consistent large-scale ontology in the world. And I've released that on my download site at SourceForge. It's under Texai as the project. And then because I believe that program artifacts ought to be stored in knowledge bases, I wrote what I call an RDF entity manager that takes ordinary Java objects, so-called POJOs, and uses a modern feature of Java called semantic annotation, and is able to persist Java objects to a knowledge base. Now, in current practice, this is normally done to a database, but I saved Java objects in the Sesame Quad store, which is a high-performance Sparkle-compatible RDF store. The next thing I did was I converted WordNet 2.1 to RDF, and now there's a number of different RDF implementations out there of WordNet, but this is a faithful implementation of WordNet 2.1. And although WordNet is on version 3.0, 2.1 has a great deal of this coverage. And then after that, I converted the Cmu Pronouncing Dictionary to RDF. Now, the Cmu Pronouncing Dictionary uses a symbol set called the alphabet, and that gives the phonetic sound pronunciations for each of the components of some 60,000 English words. And then I created the Texai lexicon, which is a merged content of the OpenCyc lexicon, WordNet 2.1, the Cmu Pronouncing Dictionary, and I also took the Wiktionary. You may not be familiar with the Wiktionary, though it's a sister project to Wikipedia. It has a very large number of English word senses. And where there were not conflicts, I merged the Wiktionary word senses into the previous set. So this knowledge base is partitioned because it's so large. I have it available on SourceForge. It's approximately, in total, with some redundancy, it's approximately 20 million RDF statements. So it's a fairly large knowledge base. So then I was interested in a parsing technology to back up the dialogue system I talked about at the opening. And I was attracted to some work in France called the fluid construction grammar because of its high emphasis on semantics. In the same way that Arthi talked about the cognitive substrate for natural language understanding, I believe that if you're going to build a dialogue system, you need a knowledge base on the back end. There's just so much of English language that has to tie itself with grounded concepts. And so the research in France had to do with it, in Belgium had to do with fluid construction grammar lent itself. It was stemming from robotics, and I think some of the best work in natural language is being done in robotics because you're grounded in the world in which the robots or agents operate. And as a result of attending a AAAI fall symposium held in Arlington, by Dr. Jerry Ball was the coordinator of that. It was strongly suggested that incremental parsing is important. Well, what's incremental parsing and why is it cognitively plausible? Incremental parsing says that you don't treat parsing as a pipeline. You don't sweep the whole sentence, the whole utterance looking for named entities. You don't do a shallow parse, then do a shallow parse on it to find how the constituents relate to each other. And then you don't find out what concepts are mapping to each word, and then you don't do disambiguation. Rather, you do them as soon as you possibly can, word by word, like people do. And then you prune the alternate interpretations as fast as you can. This is the same method of operation by automatic speech recognizers. And so I took the existing implementation of fluid construction grammar, wrote a Java implementation that behaved the same way. Then I made small modifications to it so it behaved incrementally. That is, applying the full rule set, the production rule set, one at a time, as each word came across. Now, my current work in this project is to perform pruning of the interpretation, the highly branching, explosively branching interpretation tree. And unlike Arthi's work, where she's using argument constraints backed up by the knowledge base, my work is going to use something I haven't seen before. And if anybody here wants to help me out on that, or let me know existing work, it's called Walter Kinch's construction integration approach. It's a theory of reading comprehension that Dr. Kinch developed in the late 80s and early 90s, and has to do with setting up networks of alternate interpretations where the nodes in the network are the propositions you extract from the interpretation, and the links between the nodes are agreements between conceptual arguments in the propositions. And use spreading activation to prune out the less favorable implementation. So I have that pretty much starting to work on that, and we'll just see if that's a way to solve if Dr. Kinch's ideas work out there. So the idea would be to build an English bootstrap system. So the idea would be that if I can develop a system that will accept English input in a controlled English manner, that is, not robust for every possible sentence, but just for a few sentences, I might be able to build a system that can acquire linguistic skills and linguistic knowledge and be widely used across the internet by a large multitude of people. So that concludes my own remarks for a little bit of time. And then I'll join our other panelists to take questions. And I have some